Welcome to the SQL interview and real world query masterclass. This playlist is different from a sequential fundamentals course. Each video solves one very common SQL problem that shows up in interviews, Stack Overflow questions, and real analytics work. Today, we start with one of the most important debugging topics, inner join versus left join. The goal is not to just memorize the definitions. The goal is to understand why rows disappear, why rows multiply, and how to verify joins before trusting your totals. Let us start with the pain point. In the real analyst work, join errors often do not throw error message. The query runs successfully, but the report is wrong. There are two common problems. With inner join, rows can vanish because SQL only returns records that match on both sides. With the left join, rows can bloat because one parent row can match many child rows. In healthcare analytics, imagine 100 enrolled members but only 70 members have claims. If the report is about utilizing among members with the claims, an inner join might be fine. If the report is about all enrolled members, an inner join would silently remove the 30 members with no claims. Before we compare giant types, introduce the most important word, grain. Grain means what one row represents. Members is usually one row per member. Claims is usually one row per claim. Claim line is usually one row per service line. When we join one row per member to many rows per claim, row counts naturally change. Connect this back to real world data modeling. A join failure is almost always a mismatch of table grains. If the population table is one row per member, but activity table is one row per claim or claim line, SQL is not confused. It is the grain you gave it. This is not automatically wrong. Row multiplication is correct if the output should be at the claim grain. It is wrong if we wanted one row per member. Inner join is the strict match join. SQL keeps only records where the join condition finds match in both tables. In this example, Maya has claims and Carlos has a claim, so they appear. Amina has no claim, so she disappears from the result. This is correct when the question is show members who had claims. It is dangerous when the question is show all members and their claim activity, including zero activity. Left join is often described as preserving the left table, and that is true, but it does not mean the output row count will equal the left table row count. If there are zero matches, the left row remains and the right side columns become null. If there is one match, it behaves like 1 to 1. If there are multiple matches, SQL repeats the left row once for each matching child row. This is why left join can fix disappearing members but still create inflated aggregates if we do not manage the grain. A professional analyst does not simply write the join and move on. They run sanity checks first. First, count each base table. Second, check whether the key on the right side is unique. If the right side has a multiple rows per key, the join can multiply rows. Third, count the joined result. The joined count is a diagnostic signal. If it is less than members, rows probably disappeared. If it is greater than members, you probably have one too many expansion. Either result may be correct, but you need to know why it happened. The first bug pattern is disappearing rows. This happens when the report is supposed to preserve full population, but an inner join removes records with no match. For example, if the business asks for all members and their claim activity, inner join is too restrictive. Use left join from members to claims, then handle Missing claims with null, 0, or no claim flag depending on the report requirement. The key is not that left join is always better. The key is that the join type must match the business question. The second bug pattern is row bloat. This often happens when the final report is at higher grain than the joint child table. If claim has multiple rows per member, joining members to claim can create multiple rows per member. If you then aggregate at a region or plan level, that might be valid for claims totals, but it can inflate member level metrics or duplicate member attributes. A safer pattern is to aggregate the child table first. In this example, claim is converted to one row per member inside the CTU common table expression. Then we join member level claim totals back to members. This is one of the most important left join traps. You write a left join to preserve the population table, but then you add where condition against a column from the activity table. Use this exact phrasing in the narration. If you filter a left join table in the where clause, you destroy the preservation property of your left join. The query starts behaving like an inner join for that filter because unmatched right side columns are null and they fail the where test. For example, condition like where c dot claim amount is greater than or is equal to 500 or where c dot claim status is equal to paid removes member with no matching claims because null does not satisfy the filter. To preserve the population table, put the right side condition inside the on clause or use conditional aggregation when you need filtered metrics without removing the left side row. Here is the decision framework. Do not start by asking, should I use inner join or left join? Start by asking what the business question needs. If the report only needs matching records, use inner join. If the left table defines the population, use the left join. Then ask whether the right side can contain multiple rows per key. If yes, you must decide whether to aggregate, deduplicate, or intentionally work at the lower grain. This slide also gives you a strong interview answer. It shows that you understand both the syntax and data quality risk. Now let us move to SQL Server Management Studio and see these join behaviors directly in the data. The purpose of this demo is not only to compare inner join and left join syntax, we are going to track what happens to the row count, understand why rows disappear or multiply, and then fix the query so that the result matches the business requirement. Before joining any tables, we need to understand the size of each source table. This is a professional habit that makes join problems much easier to diagnose. First, I will count the rows of the member table. This table represents our complete member population. The result tells us how many members exist before any join takes place. Keep this number in mind because it becomes our baseline for evaluating whether members later disappear or whether rows expand. Next, I will count the rows of the claims table. This table is at a different grain. One row represents one claim, and the same member may have multiple claims. Notice that the members table and claims table do not necessarily have the same number of rows. That is not an error. They represent different business entities and different grains. The members table is one row per member. The claims table is one row per claim. The grain difference is the reason a join can change the row count. Now I will join members to claims using an inner join. An inner join returns only rows where the member ID exists in both tables. Therefore, Any member with no matching claims is excluded from the result. Compare this result with original member count. If the numbers differ, that is expected, members without claims have disappeared because an inner join requires match. Also remember that this count is a count of joined rows, not necessarily a count of distinct members. Members with multiple claims can appear more than once. Let us inspect the first 20 rows. Here we can see the member information alongside claim ID and claim amount. If member has more than one claim, that member appears once for each matching claim, but a member with zero claims does not appear at all. Now I will run the same relationship using left join. A left join preserves every row from the left table, which is this query is members. If member has no matching claim, the member still appears and the claim columns are written as null. A common misconception is that left join always preserves the exact row count of the left table. It preserves the left side population, but it does not guarantee one output row per left side row. If one member has three claims, that member produces three joined rows. That is row expansion caused by one-to-many relationships. In the detailed results, members with no claim show null in claim ID and claim amount. Members with multiple claims appear on multiple rows. This is why we must always ask, what does one row represent after the join? Is it one member, one claim, or one member claim combination? Next, I will group the joined data by member and count the number of matching claims. The having clause limits the result to members with more than one claim. These are the members that cause one left side row to expand into multiple joined rows. The query also calculates each member's total claim amount. Row expansion itself is not automatically wrong. The danger appears when we forget that the grain change and then aggregate columns from another table at the expanded grain. That can inflate counts, financial totals, and averages. Now we'll examine one of the most important left join traps. The business rule is to retain every member but only attach claims with a claim amount of at least $500. In the first query, the claim amount condition is placed in where clause. The left join initially preserves members with no claims and their claim amount is null. But then where clause evaluates whether null is greater than or equal to 500. That condition is not true. The row is removed. This is the key point. Null fails the where condition. By filtering right side column in the where clause, we destroy the preservation property of the left join. For this condition, the query behaves like an inner join. Now I will move the same claim amount condition into the on clause. This changes the meaning. Every member is still preserved, but only claims at least $500 are allowed to match. Members without qualifying claim remain in the result with null claim columns. The professional rule is simple. If you must preserve the complete left side population, place right table matching condition inside the on clause or use conditional aggregation when calculating metrics. Now let us solve the row bloat problem correctly. The business requirement is one row per member. Claims table can contain many rows per member, so I will first aggregate claims to one row per member ID inside the common table expression CTE. Inside the CTE, we calculate the claim count, total amount, and highest single claim amount for each member. After the group by, the CTE now at member grain, one row per member ID. We can now left join that one row for member result back to members. This preserves all members without multiplying rows. Coalesce converts missing claim counts and missing claim totals from null to zero because a member with no claims should show zero activity rather than an unknown value. Notice that highest single claim amount remains null for members with no claims. That may be preferable because there was no individual claim amount to evaluate. This demonstrates null and zero should be handled according to the meaning of each metric, not replaced automatically in every column. Now we will answer a realistic reporting question. Which insurance plan has the highest total claim amount while still including members who had no claims? We keep the member level claims in common table claims CTE common table expression, join it to the members and then join insurance plans using the plan ID. The query calculates the number of members in each plan, the number of members with no claims, total number of claims, total claim amount. Because claims were aggregated member grain before the join, each member contributes only once to the plan level member count. This is the entire lesson. A join failure is often mismatch of the table grains. When your expected output is one row per member, first convert every many row activity table to one row per member before joining it to the final report. Finally, here is another safe pattern. We preserve every member with left join, but count and sum only claims of at least $500 using case expression inside the aggregate functions. Because the $I condition is inside the case expression rather than where clause, members with no qualifying claims are not removed. Their $I claim count amounts are written as zero. Let us summarize what we observed. Inner join removes left side rows that do not have match. Left join preserves the left side population, but one-to-many relationships can still multiply rows. A right table filter in where clause can remove unmatched rows because null is fails in the condition. The safest workflow is define the required output grain, inspect the row counts before and after the join, place preservation sensitive filters in the on clause, and aggregate many row tables before joining when the report requires one row per business entity. Now that we are seeing the row behavior directly in SQL Server, let us return to the closing slide and review the professional join checklist. Now we have seen that choosing between an inner join and left join is not only the syntax decision, it is a business decision based on which population must remain in final result. For this practice challenge, the business request is return one row per member with the total claim amount and members with no claims should display 0. The expected grain is very important here. One row per member. That means we should begin with the members table because it defines the complete population. We should not begin with claims because members with no claims do not exist in the activity table. The next question is whether the right side table can contain multiple rows for the same member. In this case, yes. One member can have many claims. Therefore, joining directly to the raw claims table would create multiple rows per member and would not meet the expected grain. A professional solution is to first aggregate the claims table to one row per member and then left join that result back to the members. After the join, members with no matching claims will have a null total. Because the business request says they should show 0, we can use coalesce to replace that null with 0. Before accepting the result, use the checklist on the right, which table defines the population. Can the right table contain multiple rows per key? Should missing activity remain null or should it display 0? And finally, did the row count change for the reason we expected? These questions help us protect the required grain and avoid both missing rows and inflated totals. In the next video, we'll take this idea one step further and focus specially on finding records that exist in table A but does not exist in table B. We'll compare left join, is null, not exists, not in, including the important null trap that can cause not in to return unexpected result. That concludes lesson 1 of the interview and real world masterclass.